Everyone knows that rockets are the only way we've ever sent humans into space. But what if we didn't need rockets at all? What if there was another way to escape Earth's gravity? Something cheaper, safer, and reusable? Could we actually reach space without a rocket? Well, let's find out. Before we explore alternatives, let's talk about why rockets are currently the only way we reach space. The biggest challenge isn't just going up, it's escaping Earth's gravity. To officially enter space, we need to travel at least 100 kilometers, 62 miles up, where the atmosphere becomes so thin that it can no longer support conventional flight. But here's the catch. Going up isn't enough. To stay in orbit, like satellites or the International Space Station, we need to be moving sideways at around 28,000 kilometers per hour. Rockets achieve this by burning massive amounts of fuel to generate extreme thrust. But rockets come with some big drawbacks. Expensive. A single launch can cost hundreds of millions of dollars. Wasteful. Most rocket parts aren't reusable, making spaceflight inefficient. Dangerous. Rockets are essentially controlled explosions, and failures can be catastrophic. So, could we replace rockets with something else? Let's explore some wild ideas. Idea number 1. Climbing a ladder to space. All right, let's start with something simple. What if we just climbed a ladder to space? I mean, ladders work just fine for reaching high places. Why not make a really, really big one? One that stretches all the way to space? How tall would this ladder need to be? To reach space, our ladder would have to be at least 100 kilometers tall. That's about 12 times taller than Mount Everest. Let's assume an average human can climb 15 meters per minute, about 50 feet per minute. That's roughly the speed of climbing a standard fire escape ladder. At that rate, climbing 100 kilometers, 100,000 meters, would take about 100,000 meters divided by 15 meters per minute, equals 6,667 minutes. That's about 111 hours, or 4.5 days of non-stop climbing. Of course, no one can climb for 4 days straight, so let's say we take breaks. If we climb for 8 hours a day, it would take about 2 weeks to reach space. Could we actually build this ladder? Now, here's the real problem. What would we make this ladder out of? The taller a structure gets, the heavier it becomes, and at some point, it collapses under its own weight. Even the strongest materials we have, steel, titanium, even carbon fiber, would buckle long before reaching space. And let's not forget, a ladder needs to be anchored to something. You can't just lean it against a cloud. It would need massive support structures or be attached to something in orbit. Which brings us back to rockets. While a space ladder is a fun idea, it's just not possible with current materials. And even if we could build one, climbing for 2 weeks sounds like a nightmare. All right, let's try something else. Idea number 2. The space tower. If a ladder is too flimsy, what about a giant tower? Imagine the tallest skyscraper ever. But instead of stopping at a few kilometers, it just keeps going up for 100 kilometers. The problem? The tallest building today, the Burj Khalifa, is 828 meters tall, less than 1% of the way to space. To reach space, we'd need a tower 120 times taller than the Burj Khalifa. No known material is strong enough to hold up under its own weight at that scale. So, while a space tower sounds cool, it's impossible with current engineering. Idea number 3. Magnetic launch systems. Instead of building up, what if we used technology to launch into space, without rockets? One idea is a magnetic launch system, like a giant railgun that shoots spacecraft into orbit using electromagnetic acceleration instead of fuel. How would it work? A long circular track or rail would use powerful electromagnets to accelerate a spacecraft at high speeds. Once the spacecraft reaches enough velocity, it would detach and continue flying into space. Pros and cons: no need for heavy rocket fuel. Reusable and efficient. Acceleration would be extreme, possibly fatal for humans. If not designed properly, the spacecraft could burn up before reaching orbit. For now, it's not ready for human space travel. Idea number 4. Balloon to space? What if, Instead of launching, we just floated to space. High-altitude balloons have already reached 40 kilometers up, carrying scientific instruments to the edge of space. Some companies even plan to send tourists to the stratosphere using luxury balloons. Could a balloon go all the way? The higher you go, the thinner the air gets. At around 50 kilometers, balloons stop working because there's not enough air pressure to keep them afloat. Even if we reached 100 kilometers, we'd still need another propulsion system to actually stay in orbit. So balloons are great for high altitudes, but they won't get us to orbit. Until then, rockets remain our best option.